All right, welcome to another coding session. Just remembered I need to turn my timer on so I know how long I'm going for. Okay, we're ready. We've got our tea. Okay, so what are we going to work on this time? Bangalang, obviously. Continuing with Bangalang. The next feature I have on the list is Swizzling. So we're going to get our swizzle on. If you're not familiar with Swizzle, I'm guessing probably quite a few people are not so familiar with Swizzling, because it's usually only in graphics programming languages, like only in shading languages. The idea is that if I have foo, which is a vec3, I'll give it some values 1, 2, 3. Maybe I'll go 2, 4, 6. Then I should be able to go bar equals foo dot like zyx. Or I should be able to also just be able to go just dot x or something, or dot xy. Any combination of x, y, and z. For my language, I'm going to limit it to 4. You wouldn't be able to do 5. 4. Yeah, I could do like xxxx, whatever I want, any combination, and it'll take, this one is x, this is y, this is z. And if I had a vec4, then the fourth one would be w. You could have w as well. You can also do RGBA. You can also use these letters to reference the first, second, third, and fourth elements of the array. So basically, if foo is an array of floats, then we should be able to do this kind of, so it's a member notation, right? It's like dot this member, and this member is composed of x, y, z, w, RGBA, and the way that those letters are arranged determines what bar will be composed of and how big bar is. And you could even, this is a bit weird, but you could even combine them. I could do RGBX if I wanted. I don't see a problem. And this is kind of a special case because bar would be an array, right? It would be an array that's 4 long because there's 4 things here. Because this is only 1, it feels a bit silly to create, and it's not that convenient, to create an array that is 1 length. So instead, this would just return a float. So it's just like accessing an element of the array. That's what we want to implement. I think, because I like to do this just to keep things simple while I'm trying something new, let's just comment out like everything else. And I don't know if we have tests turned on. No, we haven't turned off. Okay. So now let's try this. I think right now if we tried this, it would say that this is not a real member. Yeah, it's not a member of foo. So let's make this a valid member, I guess is the first thing to do. So we're going to type checking. It would be an identifier. So it's a member that we're talking about, and it's a member of an array or a slice. You can, arrays and slices, you would be able to do this too. And one thing I mentioned, like I said that it was normally in graphics programs, like GPU languages. The only CPU-based language that I've ever seen this in is Odin, the language that I've been using. And Gingerbill, the creator, said the reason he included it was because the hardware supports it, so why not allow a way to use the hardware instruction? We do already actually use that instruction. So I'll show you as we go, but anyway, I guess I just wanted to say that. So if we're dealing with a member of an array or slice, the 2 members we support so far are raw and length. And now down here, I think what we're going to do is, I think I'll make a separate procedure because I feel like this main procedure is getting really big. It might be nice to split it out a bit. For now, we'll just do like a type check swizzle member, I guess I'll call it. Semicolon. And we probably need to all return. So let's create that procedure. And I guess that would return a bool to say whether it's successful or not. And I'm going to steal this message because we're going to use this, I think. So, so we're going to get in a value, I guess. Well, no, we probably need to pass in the whole node. That's probably a good idea. Probably going to need other things from the node. Probably will need the context as well. But let's do one thing at a time. So, what's the first thing we want to check? We want to check that, I guess we want to check that it is a swizzle member. And for it to be a swizzle member, it needs to be composed of only the correct characters, right? You couldn't have just an F in there. Like if I do RGB F, let's stick to XYZ, but I'll put XYZ F. This should be not valid. So we need to have a list of all the valid ones. Swizzle values, I'll call it. And I guess they are rooms. That's like the char type in Odin. So it's like X, Y, Z, and W, and R, G, B, A. In case you're wondering why there's RGBA, that's colors, right? Red, green, blue, alpha. Those are the two main use cases for these little vectors, these little arrays. Like Vec3 is just I can show you it's in globals. It's just an alias for an array of 3 floats. And the main use case in in these shader languages for this kind of stuff, these little arrays is that they represent either 3D coordinates, which is where you get your X, Y, Z, W, or they represent colors. Those are the two main things. So that's why for convenience they have those. You can use those letters. So I guess we go for char in node.value. And then we can do like a slice.linear search through the swizzle values for our character. And I think it's underscore swizzle value and if not swizzle value. Here's a feature I just found out about in Odin. Actually, I don't think I'm going to use it here. Okay, we'll talk about it later because I'm not even going to use this mystery feature, so no point in going into it. So here I'm saying if our character is not in this list, it's not in the list, then this is not a member. I did actually want to change this member, this message, so I want to say like of type, not a member of type. So this is the member. So I guess we need to get the child type node, which is where we get the type of the first child. And then I'm going to say type name that, so print out that type. So that type should be the type of the thing that we're trying to type check the member of. And I think there are, yeah, member of, so I'm going to say here type also. So I think we should be talking about the child type node, right? Yeah, child type node. See, that's what we're switching over. Member of type. So again, type node that. And there's one other place. Well, that's module. Yeah, maybe we'll leave that one. That one's a bit different. Okay, so here we're passing on the node. Okay, so now we've figured out that all of the values are actually valid characters. The next thing is, another check we can do is like a bounds check, basically. Because you can think of all these letters as like indexing into the array. So this is index 0, 1, 2, 3, 0, 1, 2, 3. So if we have an array and we know the length, and we know that, say, it's like an array of 2 floats, we shouldn't be able to use these and we shouldn't be able to use these. So we can do that bounds checking at compile time for arrays. So if, let's get the child node, so that'll be the array node. So if child node, or is it the child? I think it is actually the child type node still that we need, so maybe we don't need that. So child node, type node dot value is, damn it, every time. If it's an array we're dealing with, so I think what I'm going to do is I'm going to say length is -1. Maybe I can use that feature here. So normally what I had thought was that in Odin you always have to use braces with a for or an if. You know, in some languages, if you have a single statement, like my language actually, Bangalang supports it, you don't need these braces. So then I can do, you know, like within the braces, I can do length equals strconf dot a to I and get children 1 dot value, which should be, this should be the length of the array. I think I've explained this a bunch of times that array type nodes have 2 children. First one is the type of the thing they contain, and the second child is the length. So, that's strconf there. So yeah, what I can do, I just need to use the keyword do, and then it will allow me to use a single statement. Put on a new line. Oh, it doesn't let me do the new line. So actually for long things like this, I mean, I guess, you know, I have the text turned up really high, but it doesn't actually look that good for a long one, so I'm going to go back to this. But yeah, you know, the idea is that you can have a do and then you don't need the braces. So I think I'm going to, in his language, he supports that for if and for for. And I think I'm going to expand on that. And I'm going to say that, you know, multiple statements in curly braces is a scope, right? And then I'm also going to say that do and then a single statement is also a scope. So anywhere where you can use a scope, or anywhere where it's expecting a scope, you could have do and then a statement. And it knows that that statement is contained within a scope. Anyway, when I actually do that, we'll go into it more. Got sidetracked a bit there. Okay, so now if length is not -1, that means that we're an array and we know the length. So here, so I think we can go like swizzle index, and we can say, well, maybe I'll say index equals, so we get the index of the value. So what I was thinking, but didn't get to, was that we could do this, rearrange it like this. BA. So these two are the first ones, these are the second ones, these are the third ones, and these are the fourth ones. So if I take the index of whatever it is, say this one is index 1, and I divide it by 2 using integer math, I will get 0. If I divide either of these by 2, I get 0. This here is index 2 and index 3. If I divide them by 2, then I get 1. These two, I divide them by 2, I get 2. So I get, you know, the index of the original array that we're trying to go into. So I just say swizzle index divided by 2. That's the index that we're trying to access. And if index is not -1, so that means we're dealing with an array, and index is greater than or equal to length. Does that sound right? Yeah. Yeah. Because it should be less than length. The index should be less than the length. So if that's the case, then we have an error. Which is like an out of bounds error. So maybe I'll look for an out of bounds message. So it's like this. Index out of bounds. But then I might put an extra thing like swizzling with value. And then I think you put C for a single character. So index out of bounds, so that's like index I. Oops, I forgot to put my phone on. Do not disturb, I'll do that in a second. So what's our swizzle value? This one. No. Okay, this is a bit weird. That's not it. Char's what we want. So index out of bounds. So even with this type checking, we should get some nice errors. Yeah, this is not a member. We still get that because it has an F in it. So if we take the F away, no, we get a crash. Let me just put my phone on do not disturb. There we go. Now I know that I haven't there's going to be issues still, so I'm not surprised that there was an error, but I feel like this, oh no, actually it's like if we put a W here, then that should be out of range. Yeah, index 3 out of bounds, swizzling with value W. Okay, because we had an array of 3, so 0, 1, 2, 3. This is index 3, so that's out of bounds. Cool. I'm not worrying about this for now because we're type checking, but we haven't implemented generation and stuff, so I'm expecting there to be errors. So is there anything else that we can check while we're here? Okay, so one other thing I wanted to check was you should not be able to have more than 4 characters here. And the reason for that is, for one, it feels a bit weird, like when you're using these convenience things to go above 4, I don't really see a use case for it. And second, at least currently, we're using the XMM registers, which can only hold 4 floats. So if I tried to do more than 4, the hardware doesn't really, with the instructions we're using, it's not really supported. So I think the easy thing to do is just to say you can't have more than 4. I might put that after this loop, because after this loop we've established that it's a valid swizzle So then I can say something like cannot swizzle with more than 4 values. And that's basically, this is the value this is the member that we're trying to access. So if that member, the length of that is greater than 4, that's not valid. Oh, well, let's come across that W first, so let's put 2 X's. Cannot swizzle with more than 4 values. Cool. Okay, I think those are all the checks that I wanted to do. The next thing, which is the major job of type checking, is to add the correct type information to this node. So what is the correct type information? Well, we're going to output an array of floats. Oh, actually, that's a point. At the moment, we're allowing this on any type. Okay, so I think we should put another check and say if the first child of that type, so this is getting the type of the element in the array, and at the moment I'm going to only support this for F32. 32-bit floats. Because if we get to 64-bit floats, then there's only actually 2 values that you can put in the register. You can fit 4 of these floats, but only 2 64-bit floats, so that's a complication. I think it's also probably not a common use case, so for now I'm just going to say 30-bit 2-bit floats only. We could improve that later. And I think this is a good error message, just not a member. Okay, so now we've established that we're definitely dealing with float 32s. We need to add the type information. So there is a special case. Remember, this guy here only has 1 character that we're swizzling with, so in this case it's just a member access. So if there's only 1 value, then I think we just take this type. So this is the float type, this node. So I guess we could potentially say element type node. Maybe that's a bit clearer. Then we can say down here that we want, there's just the type of the thing that you get as a result of the swizzle is just the element type node. Otherwise, we'll create a new type node. And that type is going to be an array. We always output an array. We always know the length of it, so there's no point in creating a slice. We can just create an array. Type node.children. So the first child is this, the type of the element, and the second child is the length of the array, which is the length of this, right? It's this length. So maybe we should take that off. So in this case, it's 3. If we did another X, that would be 4. This array would have 4 elements. This array has 3, this array has 2, like that. So basically we want this as this value. And I think the way that I'm enjoying doing this now, or the easiest way I think to do it, It's just something like this. I find that a bit easier to use because previously I was using strconv to do an I to A, but then you have to supply a buffer and everything. This is just a bit cleaner. Has it done a terrible import? Yes. Okay. So I think that's our type node. So let's append that like so. I think that's type checking done. I think it's pretty good anyway. Got quite a few checks in there. Type F32 question mark cannot contain non-fixed array types. Line 12. So this should be a length, so this actually should be a number literal. Yeah, that's a good catch. Okay. So it didn't even crash or anything. I mean, I imagine this outputs some dodgy, stupid assembly. This is creating the array, it looks like. This is the exit, so then we have two assignments in between. And I kept OS there because I wanted to do like an os.exit. So we can do like bar 0. If I do like zyx, then we'll get to bar 2 later. But if I do zyx, then z is the first element of this, so 6 should be the first element, so this should return 6. We need to cast to U8. Interesting. Did it say 69? No, 67. Okay, so this is this crazy instruction here is converting from a float to a integer. And my guess is that it does not like to convert to such a small integer. Where's our conversion code? Maybe we can fix that up quickly. Yeah, this is it. So if we're dealing with a float and we're going to an integer, this is that crazy conversion. Dest location is what we return, and it's just a register of the correct size. But this conversion doesn't like that size. I think what we can do is just like for this here is use a bigger register. We'll just use a 64-bit register to convert into. But then because we're still returning this one, which is a smaller register, we'll use the same register number. That'll implicitly perform the conversion down to a smaller size, because converting to a smaller integer size is basically just using a smaller version of the same register. That's all you have to do. Then it just truncates. So if we just change this, it's kind of like, I don't know, 64-bit dest location. Oh, let's say large dest location. So it's the same as this, except instead of dest type node, we will use let's say large type node. Value equals slope U64. It doesn't matter if it's signed or not. And then we use that to create the register location. So that'll use a 64-bit location. So then the only difference we should see in this code is that this should change to, is it just R11? Yeah, changes to, and then we get exits code 0. So it worked. I mean, bar 0 should not be 0, but we haven't implemented the swizzling properly yet. So I think that's right. Okay, so we fixed up some conversion. Right, so type checking is done. Generation, we'll go to identifier as well. This looks like the same code, so we're saying it's a member and it's an array or a slice. Because of type checking, we know now that if it's not either of these, then it must be a valid swizzle. So how do we swizzle? I think in assignment, yeah, I was looking at this before. We have like some crazy stuff here, but we're going to look at the simpler stuff up here. This is where we do some other vector stuff. So this line here is this move unaligned is for moving stuff into a SIMD register. So move it into a register that can hold 4 floats. Looks like we need to import format. And it looks like we need precision and we need some locations. So I think the location we're going from will be the child. No, I think it's the raw location of the child. Because the raw location is where the data is. I think I normally call this address location when I grab it. Yeah, address location. So I don't know if this is right, but I'm just going to throw that in there for now. And we want a register to put it in, right? So I think we can just create a register with this register num. Oh, but we have to be careful because we already have created a register with that number. I mean, this should always be, it's an array, so that should never actually be a register location. So I think it's safe. I think it's safe. That we create a register location, and we should be able to just say the register at register num, and the type is child type node dot children 0. So again, the child type node is the array or the slice that we're swizzling. So its child is going to be the type of the element in that array, which should give us the correct register to hold that element, which in our case is a SIMD register. We need the precision. I think we also, yeah, we needed that here. So grab this. Let's just put that up here. Element type node, that was this. So I guess we need that to be like that. And then we could just, that's a bit clearer. We can say element type node, which is already a pointer. Okay, so let's try running that. We should at least get a move. This is our exit. So it should be here. Yeah, we get our move UPS. This one is the special case. Maybe we can handle that first because it's the easier of the two. It's like, you know, if talking about 1, then I guess we need to get the index corresponding to the letter. I think it could be nice actually, because that's kind of what we do here, right? Getting the index of the letter, we search and we get the index and then we halve it. I wonder if we could extract that out. Type checking. It's not really type checking specific, but like get swizzle index. Then we can move the swizzle values here. So it's like char rune, and we slice. So then we look for it, and if there's not a swizzle value, we'll return -1. Otherwise we'll return that. So we're returning int. Yeah, that's pretty much it. That should convert one of these letters to a valid index within the source array. So then we should be able to use that here. Just say index, let's get swizzle index with the char. And if index is -1, that means we didn't find it, so that's that error. And then there's that error. And then over in here, never feels that great to do this. But we can do type checking to get, like, I feel like it feels weird to say this is a type checking thing I'm grabbing, but whatever. So I guess that's the first one of that, and then we say index is the result of that. Type U8 to rune. Oh yeah, sometimes in Odin, when you do things with strings, you get just a byte back, and sometimes you get a rune. But maybe I can just cast to a rune. Is that like an easy, cheap way to do it? Okay, seems to work. So now we have the index. So all we should have to do is go, location is the child location, so that's the location. No, not the child location. Again, we want this raw location. We want the location of the actual data, so I guess we always need this. Do we always need a register location? No, I don't think so. But we always need this, I think. So this is the address of the data. And then we want to offset it by index times, we need the element size also. That's how far we need to offset into the array, and then we can return that location. So this stuff we also need. I'm a little bit dubious about this, whether this is going to be quite right. I guess we'll find out. Yeah, let's see what we get with this. So this is creating the array. Then there's this access, and then the exit. So creating the array, that this one here, yeah, see, we're doing a load effective address. And then we're copying into, I feel like that's not quite right. So we allocate 4 bytes, that's right, for a single element. But then this kind of, so we're getting RSP plus 16, so that's the start of this array. And then we're saying that that's an address. So when we do alia, basically we're saying that this becomes an alias of this. So this is like RSP plus 16. And then I think we again need to dereference like this to get the value at RSP plus 16. Right? Yeah, so if this was y, then it would become RSP plus like 12. Oh, it still says 16. Well, let's fix the, first we need to fix that this address location, like, I think I can call it like a memory location is, it's memory where use that, we have an offset of 0. And I think I can just go like this. Now what happens? Okay, yeah, so this is grabbing, that's why this didn't change, because this is, yeah, always going to grab the start of the array. But now we're like saying, okay, let's go 4 bytes into the array, which means let's go to the second element, which is y. So I feel like this here, this line here, is correct. This line is kind of messed up, especially here. It looks like for the same reason, you know, it should be in square brackets, this guy. Yeah, so I guess we should be using the memory location as our input. Okay, and I'm just going to return bar2 just to double check that it should return 4. Perfect. So this line I'm happy about. This one, 0, this should return 6, but it crashes, I think. Oh no, it just returns 0, doesn't it? Yeah. Okay, but that's okay, because all we've done is move stuff into here and then done some stupid copy that doesn't make sense. So once we move it into the register, then we need to actually work on it. Okay, and to work on it, we need to do the swizzle. Instruction. And that's this here. So this code here, which we're also going to need to use, is for taking the memory that's in that SIMD register, so taking those 4 floats, and say we only need 3 of them, or, well, this line here will move all 4 of them out to memory, but if we need less than 4 out to memory, we can't just do this, otherwise we'll override some stuff we don't want to. So this code here loops through and grabs them one at a time. It grabs the leftmost float, and then it uses this shuffle command to shift all the floats to the left, and then the X will go over to the other side, so that we can then loop around and move the left one out to memory again. And this shuffle command is our swizzle. That's our swizzle. You just apply the register location twice. But we just need to make sure that this OX39 is correct. This was hard-coded. Let's say swizzle. This was hard-coded to do that shift operation. So now I want to make another kind of utility, which is like to shuffle code, and we'll pass in our node value. I guess we can put that in util maybe. Wait, that's type checking util. Here we go. To shuffle code, which is also a string. And we pass in a swizzle values. I'm going to use a string builder for this. Maybe it's overkill, but strings.builder. So then we need to init the builder, and would be good to also defer destroying the builder. Then the first thing we want to do, format.sb print, just fb print into the shuffle code is 0b, because we're going to write this shuffle code in binary. So 0b denotes binary at the start, just like you might be familiar with 0x is for hex. This is for binary. And at the end, we're going to return toString of, I don't think I need a pointer there, of the shuffle code. But a little gotcha is that this here is going to return like the internal string of the builder. But because we're destroying the builder, it's like going to turn to garbage after we return. So you can do this clone to clone the string and safely return it. Okay. Now when we go for in swizzle values, we can say, well, I guess again we can do get the swizzle index. Damn it. Get the swizzles index of our char. I guess we need to import type checking. We get the swizzle index. Then we can say, like, switch on the index, I guess. And index, oh, I need to do case. So if it's index 0, we're going to print the binary 0, 0. 1, 2, 3. So we're just going to print the binary versions. Oops. Of these numbers. So this is kind of how it works. You create a binary number where these 2-bit parts represent the source float that you want to put into the output. You want to put, so if there's an index 0, which would be an x, right, in the swizzle, that means that where you had the x in the swizzle, we want to put the thing from index 0 in the source array in that position. And so we're going to construct this to do that. I don't know if that made sense. Hopefully it makes more sense when we see some output code, which I think we can have a look at now. Here we go. So here's we've done our swizzle. So here we're saying, okay, first we're going to put, this is binary for 2. So we're going to put the thing at index 2 of the source array here. Index 2 of the source array. And we're putting it first because Z is first. Index 1, index 0. Y is index 1, X is index 0. This might not be right. I get a bit confused with ordering because if we go over to Grok here where I was learning about it, see it says like we're doing a reverse swizzle, right? And then it will explain like, okay, so the first thing you're putting in W is at index 3. So index 3, that's 1, 1 in binary. But then when it creates the binary number, it actually puts it at the end. Like it reverses them all. So that I find a bit confusing. So we might need to reverse this ordering, but I guess we'll find that out. So now that we've put it into the register, we've swizzled the register. Now we need to get back out again into memory, and that's where this code comes in. This guy right here. And I might put that in like the, I feel like that's kind of copy, except it's kind of like copy 4. I don't know, I feel like that's probably terrible naming, but it'll do. So we have like a source destination. And we also need some type information. So I guess we'll pass in like a type node. This comment, that's right. I wanted to like clean this up actually. Maybe we can do that while we're here. Yeah, what I wanted to tidy up was because I keep doing this, when really I should just say the default is copy, and that's it. And then just use comment. Instead of saying if they don't pass in 1, then we'll like create a new variable to represent the default. It's like kind of a waste. And we could do this do return. I like that. I like putting things in one line like this. I think it's kind of really, I like to have it really compact and concise. It's nice. So this is another final comment that we don't need. Copy to register. Just say comment. Do. So all of this is getting a lot more compact with these few changes. And this code here is basically copy to register. It's just we have an extra check here. So I'm just going to put copy to register. Can't remember what we need. Maybe this is number, comment. Yeah. Yeah. So much more compact. Okay. No, we got past that sidetrack. So type node is going to be the type of the array. Yeah, and it's the array we're copying to, which is, in our case, is always an array. I was just thinking, whenever I think of an array and links, I'm like, oh, but what if it's a slice? Because we don't know the length of a slice. But we know in this case, at least in our case, that it's going to be an array. So we can just do this to get the length. A to I. Looks like we don't have strconv. Okay, so if length equals 4, this is the easy case because it's just the reverse. Right here is where we move it into the register. And then this is just the reverse, moving it back out. We need the precision. So we need the element size. And the precision. This is the type node in this case. So there's the precision, and we're going from source to dest. So source should be registered, dest should be memory. Maybe I'll just assert that. Yeah, this copy 4 is very limited. It has to be from register to memory. Okay. So now, in the more difficult case where we have to like do it one by one, this left-hand side, well, I feel like this is where we're copying to. So this is our destination. And I'm going to make a copy of the destination called out. So we're going to move to out. We'll deal with this loop stuff later. So it's from source to out, and then we need to swizzle source, which is like specifically a shift left. I'm going to replace this later on with our function that makes these codes, so it's a bit more explicit what we're doing, but we'll leave it like this for now in case my procedure is broken. Now these loops. So I feel like it can be indexed in less than length. And this one is like if index is less than length minus 1. And we can take that out. So say there are 3 elements in the array that we're writing out to. So this is going to go through this loop 3 times, but it's not going to do this in the last iteration, because first we move a float out, then we shuffle so that the next float is ready to get taken out, and then the next iteration we move it out. But there's no point in shuffling right at the end, because we don't need to do another move, so there's no point in doing that shuffle. But there is the copy 4. So I think we can go back to wherever the hell it was. This is where we're doing it. And do our copy 4. Source is the register. Memory location is, oh wait a minute. Memory location is the original array or slice data. We don't want to go back to there. We actually want to create a new array. So we're going to need to allocate a new array and then copy out to the top of the stack. That's what we need to do. And do we have the type node? Type node. So this should be the type of the array that we're copying out to. This is out. So this should have the correct size for the swizzle data. Yeah, and because we're allocating, we're going to need to do some other funky stuff like return copy stack address, offset 0, register num. So how much do we need to allocate? I guess it's the byte size of this type node, right? Okay, and another thing that I've just realized, because we're doing this allocation, I really don't like this stuff and I want to avoid it more often. When we have a look at the assembly, you'll see why. It's kind of ugly and does a lot of work that it doesn't need to do, I feel like. It's probably not so much of a penalty, but I don't like it. But to make sure that this works nicely, we need to, in our expressions, we need to keep track of when we are needing to allocate. So I have this contains allocations, and you pass in an expression node and it will tell you whether there will be allocations within it. So we need to add to this and say if we have, this is an expression, so if we have a node where the type of the node is an array, no, I guess it's the child node, right? No, I think we can say if the type of the node is an array, no, I'm getting confused now. So the child will be the array itself. The parent of it will be the member. In the AST, the member is the parent of the object. Yeah, like see this here is like the object, and then this is the member. Foo is the member of blah. That's how it appears in the AST. So if we've come across somewhere where it's an identifier, and the first child is not a type, it could be, because if this is just an identifier or something, then the identifier needs a type, and that could be the first child. But if it's not, that means that it's like a member, in which case we can say, okay, if the type of the thing it's a member of is an array, and this is such a messy, and node.value does not equal raw. So we're a member of an array, we're not raw, we're not length, which only leaves Swizzling, and I think the node.value is greater than 1, because remember, if length is 1, that's our special case, and we just do this, so we don't do any allocation. So this crazy big condition should say that we're doing a swizzle. I might just put a breakpoint there to check it. But so we're doing an assignment, left-hand side node is, yeah, so that's our swizzle. Seems like this is throwing an error now. Oh, well, I got that around the wrong way. So I'm kind of surprised that that didn't trigger actually. Now it does. We should be copying from a register. Ah, so when you just say equals, I get a bit confused with assert sometimes. So if this condition fails, then, so the source needs to be register, destination needs to be memory. Yeah. Okay. We've got output 2 this time, that's interesting. Oh, because we have implemented it all, I think. Yeah, so now we do an allocation for the output array, and now we move, say we move a float, this S is scalar, so we move a single float to here, then we do our shuffle, shift left, then we move a float to the second part of element of the new array, then we shuffle again and move to the third element of the new array. We take a copy of the address of the new array before deallocating it, and then copying it out to this allocation. See, this is what I don't like. This whole here is a waste. Don't need to do this, don't need to do this. Really, we could just go directly to this allocation. But because we do the second allocation, then we need to do all this stuff to copy it to the first one. And if we're a little bit smarter, we could avoid all of this basically. And this, that'd be nice. But this looks good to me. The fact that we got a 2 instead of a 6 makes me think that we have got it backwards. So if I put 2 here, do we then get a 6? This happens sometimes. I've started getting this error sometimes. I don't know why. Sometimes this args is like empty. Yeah, so now we get a 6. So I think it's probably backwards. And I found a nice way. I'm going to keep this here. It should, so then when we do a longer program, it should not trigger on. No, that's good enough. Testing's good enough. We'll keep that open. What did I actually want to look for? Oh yeah, our swizzle code. Yeah, I found out in Odin, another thing I found out about Odin because I was looking through the docs. You can do this, and then it'll loop through these values in reverse, which will effectively reverse the order that these are output. And now when we access this element, we get a 2, which is X, which is the first element of here, which is right? And if we do 0, then we should get 6, because Z is the third element, which is this. Okay. Let's just double check bar 2 to make sure that should be 4. Cool. And the other check I wanted to do is if we do a vec 4, because then we should get different code here. It should just do another move to bring it out. So we'll do 248, 2468. I think we should do bar 1, so that's Y, so it'll be 4. We're still getting this shuffle code. Oh, because we have 3, we're creating 3, like the output array is still 3. So if it's WZYX, so we're creating an output of 4. So the copying out this should be 16 size, and this should be just one statement. There we go. There we go. And we still have this horrible copy business, but we can just copy it out in one go. So that's nice. And it should be Z, so that should be 6, and it is 6. I think that looks pretty good. It took us a while, an hour and 10. I'm trying to think if there's any other edge cases for this. We've done the single, we've done outputting to 4 elements, we've done outputting to 3, we've had an input of 4 and an input of 3. Oh yeah, that's right. We made that utility to shuffle code. Actually, we also made that copy 4. And then in this assignment stuff, where was it actually? Float array. Yeah, so this no, not this. This code here is our copy 4. So this is like context, and we're going from our register location to our left-hand side location, and then the type node, I believe, if we have some code like this, it should be whatever's here. So it's this one. There's our copy 4, so we should be able to cut that out. We can make a swizzle test. Go to the bottom of our general tests. Swizzle. So just say var 0, var 1, I'm just going to say zyx, var 2, I'm going to say wzyx. So those are the two different ways that we write out back to memory, 4 and less than 4, and a single. We also should check, I'm going to do w. So then instead of os.exit, well, we need to get the debug, and we'll do some asserts. So let's say var1, var1 0 should be z, which is 6. var2 0, that's var3. var2 0 should be 8. That's not an 8. And then var3 should also be 8. And because we changed, I haven't turned the tests on yet, have I? Okay, there's one other thing I want to change before I do that, before we go for the long test run. In our copy 4, I said I wanted to change this. So if I go shift left shuffle code to shuffle code, so it's X, Y, Z, W, but then we want to shift everything to the left. So basically I take the X off and put it here. That's basically the operation we want to do. So then I put that there. Shift left shuffle code. Let's just check that that all works still. So we get a 6. And what were we expecting? Bar 1. Bar 1 is a Z, X, Y, Z. So 6 is correct. All right, now let's try the whole test suite, including our swizzles. So that'll, oh dear. Foo. Oh, right. It should be var zeros. So that'll test the swizzle, but then it also does lots of array math tests like this, which also use this new copy 4 procedure. So it's an extra testing of that. And looks like everything finished fine. Okay. So I think that's success. Even tested. Wow. Pretty impressive. Pretty impressive that I actually got around to writing some tests. So let's revert all this stuff. And as a final check, fingers crossed, we should get our triangles. Ah, it's doing the tests. Jeez. I was worried for a second there. I was like, why is it not starting? Because it's doing the tests. Triangles. Cool. All right. Now we have Swizzling. We can take it off the list. Cool. Enough for today. Thanks for stopping by. Have a good one. Ciao for now.